The next project is this Emerson model 547A from the year 1948. It uses miniature tubes and it's a line operated radio. So let's get to it. I've already taken the screws out of the bottom, and there's the chassis. Has some kind of replacement capacitor here. This is a 30 and 50. 30 sort of an odd value, so I'll be using two 47 mic capacitors. Okay, before we get too far into this, I want to point out that this chassis, plugged in the wrong way, is hot. It doesn't even have a blocking capacitor. So we're going to have to address that a little later on here. I'll show you what I'm going to do. But one of the first things I will be doing is creating a polarized plug and moving this switch from the ground side to the hot side. So that will help a little bit. So here's the chassis, here's the filter capacitor. It's a 50 mic and a 30 mic. And I'm going to be using a pair of 47 microfarad capacitors. These are rated 250, which is more than adequate. There's a paper cap here, a paper cap here, another paper cap there. So we have 1, 2, 3 paper capacitors that I'll be replacing. You can see with the switch here, the connection goes right from the switch to the chassis. If we measure that, we will show a connection directly to the chassis. But the switch, like I showed in the schematic, is on the high side. So we'll address that. The other thing is there are 2 screws that come through the cabinet. We're going to have to address that issue as well. First, let's fix the chassis. We'll get rid of the paper caps and get it all working, and then address the other issues. The power cord had been cut off. It was crumbly anyway. So get it out of the way for now. Okay, with the power cord out of the way, now let us get down into this paper cap. It's really tight underneath the antenna leads here. So that cap is out. It's a 0.05 microfarads. So replacing this 0.05 with a 0.047, that's close enough. We're attaching the lead of the capacitor to the lead of this resistor here, which is the same connection that the old capacitor utilized. Okay, we'll solder that right there. Make sure it's attached well. Snip off any extra. And the other end attaches right there. We'll loop that under. And over. And throw a little solder on that. Make sure it's tight. Clip any excess off. We'll move things out of the way here. This capacitor here attaches up here. And down here. Sometimes you can't see what the value is, so you just take the hot air gun and melt the wax. And that's a 0.1. So we'll clip the leads. We'll grab our 0.1. Okay, replace this capacitor. Solder it onto the old wire. Make sure that's attached. Remove any excess. And tie it back in. Okay, we have another cap here. This is a 0.002. So we'll use a 0.0022, which is a modern value. We may be able to clean that up and actually connect one of the wires directly to the terminal here. Okay, when we get them loose like that, we can just snip them off to get it out the rest of the way. And just feed the capacitor through, loop it around. Hit that with solder. Clip off any excess. Find the other end. Make sure you have a connection. Cut off the excess. Position the cap a little better. All this wax stuff is it collects cobwebs. So here's one end of that cap. And here was the other end of that cap. And again, that's a 0.005. Again, you can always hit that with the heat gun to read that. I have a 0.0047 to replace that 0.005, and we'll throw some solder on that. Make sure we're attached real well. So all the paper caps are gone. Now we have the filter caps. And I think what I'm going to do is cut this off here, here, and here. Take the wire strippers, grab some heat shrink. We'll take the minuses. First we'll bind these together. Solder them up together. Put a little loop. Solder that up to the minus lead. Sure everything's tight. Slipper heat shrink. Put a loop. And a loop. Little solder. Cut off the excess. Bring our heat shrink up. Put a loop in here. And loop that around. Turn on our hot air. Shrink that all down. Now the wires from the output transformer look a little crackly, so we're going to replace those. I think for this lead here, since it's really short, I'm going to snip that out of there. So here's one of the new leads for the audio transformer. Nice and tight. That comes over to this pin of this tube here. Comes through here. So we need to make it long enough. That's well attached. The other lead is the red lead. Goes way, way over here. So I'm going to put a loop in that. And put a loop in this. Hook those together. The loop in that and the loop in that. Just hook those two together. A little solder. Nice tight connection. Feed this up through here where it came from. Pull the old insulation off. Okay, we need about that long. Need to make a loop. And a loop. And a little solder. When things are a little oxidized, you've got to make sure you have a good connection. Okay, so we got that side done. These are still nice and flexible. So now we have to address the power problem. There's from the line cord. And you can see how this went to ground. We no longer want to do that. So we will lift that from ground. We're going to clean those up so we can connect our wires very solidly. Going to help these along with a little bit of flux. Okay, we got that loose. We'll just pull that through. We'll try to do the same with this one here. And we'll use a little solder wick clean the holes out. Just like that. Little solder wick. And both holes are empty now. So we need a new power cord. And this one, the power cord just came through a hole. It didn't have a strain relief, and I'm not going to drill one. So let's find a power cord. I've cut the power cord here so that this is wide, so it can only go in one way. I'm going to solder that up. A lot of times they're too thick to go through on these older chassis. So I'm reusing an old cord for this application. And we have enough length. We'll make sure that the hot lead which is that lead, goes up to our on-off switch. And we'll hook that right there. Because again, this one has absolutely no isolation to the chassis. Not even a capacitor, not even a depth capacitor. That's good and tight. So the only thing we have to do yet is bring the hot lead from the switch to the rectifier tube. Okay, so I've connected the hot lead to the power switch. Just need to bring the hot lead from the power switch over to the rectifier tube. That should be plenty long. The hardest connection is going to be down here. So first thing is to connect that using the old connection from the power cord. Nice and hot. Get some solder on that. That's nice and tight. Bring that wire up into the switch. Feed that through the eyelet on the switch. Throw some solder on that. Tight connection, little straight piece, cut that off. And let's see, what are we going to do with the filter caps? We can just stick them up in there. Okay, we will plug it in the isolation transformer. First in power off condition, and then powered on. Turn it on. Dial lamp works. Noise is good.
Even as we slowly move away from it, footfalls. Innovator. This hour we're taking calls of a general.
And you know, that works so well. Works so well, I'm not even going to fool with the alignment. Normally I would go through and align this, but it picks up stations fine. It's working great. And we'll call it done. Put it back in the case. So there's all the debris from that. There's actually more debris than that, but that's what's still on the workbench here.
Vertical.
This one was written by itself.
Long as it should have been.
No.
And we're done. Now the only thing is, if somehow somebody was able to plug it in backwards, these would be at line voltage. So I'm going to get plastic screws and replace these two screws with plastic screws for added protection. Other than that, all done. Nice little 1948 AM radio from Emerson. Just a little postscript. We're going to take a look at the value of this filter capacitor. The one section is 12 microfarads, supposed to be 50. The other section is supposed to be 30 microfarads. It weighs in at only 8.9 microfarads. So this capacitor here is definitely bad. The paper capacitors, you just can't trust those. Whether they're in value or not, they're not worth trusting. So that's it on that Emerson. Thanks for watching.